Hi, in this video, I will be showing you problem number 29 of chapter 3 section 9 from the practice exam 2. Gravel is being dumped from a conveyor belt at a rate of 30 feet cube per minute. And its coarseness is such that it forms a pile in the shape of a cone whose base diameter and the height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? Round your answer to 2 decimal places. So the gravel is in the shape of a cone. It's also given that base diameter and the height are always equal. So base diameter is 2 times the radius equal to the height. So 2r equal to h. So we get a relation here connecting the radius and the height. And also it says gravel is being dumped from a conveyor belt at a rate of 30 feet cube per minute. Because of the fact that we have feet cube per minute, we are talking of volume here, the rate of change of volume. So dV by dt, which is the rate of change of volume, is given as 30 feet cube per minute. These two informations are given to us. And then what is being asked? How fast is the height of the pile increasing? How fast or how slow determines the rate? So what is the rate of change of height is being asked when the pile is 10 feet high. When the height h equal to 10 feet high. So this is what being asked in the problem. Now let's start off with the volume of the cone. V stands for the volume. Volume is 1/3 pi r square h. That's the volume of the cone. So we are going to take the derivative of this expression dv by dt, and also we are going to reduce the number of variables here. So we are given 2r equal to h. So we can substitute r as h over 2. So from here we can solve for radius, which is h divided by 2. So we are going to substitute that over here. So v equal to 1/3 pi over 3 r square, r equal to h over 2. So h over 2 square times h. So instead of having volume in terms of 2 variables, we have reduced the variable to number of variables to 1. So volume depends only on one variable now, which is h. So this is v equal to pi over 3 h square over 4. H over 2, the whole square is h square over 4 times h. So that will give us pi over 12 times h cube. Now we will take the derivative on both sides with respect to time, because it's being related rate. Volume is changing and also h is changing with respect to time. So dv by dt equal to constant, stays as constant, pi over 12. Then derivative of h cube, d by dt of h cube. So that is pi over 12. So 3h square dh by dt. So it is pi over 4 h square dh by dt. Now we will substitute the specifics that we know. dv by dt is given to be 30, and then h is given to be 10. So we have to substitute the specific only at the end of the problem. So it is 30 over here for dv by dt, and pi over 4. H is given to be 10, so it is 10 square times dh by dt. We are going to solve for dh by dt from this step. So we are going to take all the rest of them to the other side. So it is 30 times 4 over pi over 100 square over 100, or 10 square, which is 100, which is equal to dH by dt. So if you take this one to the other side, it will become 4 over pi. If you take this one to the other side, 10 square will come in the denominator, which is 100. So that's what we have written here. So it is equal to now 120 over pi times 100. That will be dH by dt. If you reduce this, it will be 6 over 5 pi, which is dH by dt. So rate of change of the height is changing at the rate of 6 over 5 pi feet per minute. If you reduce that, write that in terms of decimal, it will be approximately 0.38 feet per minute. 0.38 approximately feet per minute. Hope this video helps.